Hi guys, welcome to this page of the notes. And again, what we're doing is we're taking a look at the law of cosines based on information that we're given, the law of cosines applying, and then just seeing how that works. So I got another example problem for you here, and let's take a look at it. Lucas is hiking. He can hike at an average of 2.5 miles per hour. I want to know how long will it take him to travel from the cave, there's the cave, to the waterfall. How long would it take him to hike that distance? Well, let's see what we've been given. I have been given a side, an angle, and another side. That is side, angle, side, which is the law of cosines. We're going to need to use the law of cosines here in order to solve this problem. The law of sines will not work. This information does not apply to the law of sines. It won't help you any. So we go to the law of cosines. The law of cosines is what we need. All right, here we go. Again, you can label this stuff however you want to. So I'm going to go ahead and call this angle C. That'll make this side C. This will be angle B. So this will be side B. This up here we'll call angle A, making this side A. And then I get to use that trusty old formula, the same one every time, because you can label this however you want to. Plug in what we know, and it's a calculator problem from there. We are solving for side C. So I'm going to have 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 71.7 degrees. All right, at this point we have done quite a few of these. This is just a calculator problem. 3 squared is 9. 4 squared is 16, so you wind up with 25 minus, you'll do cosine of 71.7, you'll multiply that by 4, multiply by 3, multiply by 2, and you wind up with 7 point. Do not lose any of those decimal places. They are really, really important. It could drastically change your answer at the end if you round as you go through the problem. Don't do that. So then we wind up with c squared is going to be equal to 17.46418.106. Take the square root of both sides. 4.179 miles. Okay, so 4.17, that's how far he's got to hike, 4.179 miles to get from the cave to the waterfall. But I asked you, how long? How long will it take him? Well, he can hike at 2.5 miles per hour, and we actually saw this in the previous problem with the patrol boat and the fishing boat. The time is equal to the distance divided by the speed. So, time is going to be equal to 4.179 miles divided by 2.5 miles per hour. Don't fat finger something on your calculator, and you wind up with 1.67, so around 1.7 hours. So it would take Lucas 1.7 hours to hike from the cave to the waterfall, hiking at 2.5 miles per hour. Let's try another one. Perfect, here we go. We got a pilot. He's flying. The pilot's going to fly from Houston to Oklahoma City. The problem is there's a gigantic storm directly in his flight path. Rather than fly through the storm, he decides to change course. So what he does is, instead of flying straight from Houston to Oklahoma City, which is 396 miles, instead he heads 28 degrees from that flight path, 175 miles to get around the storm. Let's say that our storm is right out over here. Here is our storm cloud. Here, let's even we'll put a little bit of lightning in there. Ooh, bad storm. Ugh, no good. Rain, lots and lots of rain. No good. No bueno for a plane. So what he decides to do is fly 175 miles before he reaches a turning point, then flies to Oklahoma City. Here's what you're going to do. I want to know to the nearest mile. How much farther did he have to fly this non-direct route? How much farther was the non-direct route than if he had just taken the direct route? How much farther did he have to fly? Okay, here we go. Label your triangle. The angle I know, we're going to call that C, which means this is side C. I'll call this, we'll call this B, making this side B. This will be A, that makes this side A. And here we go. C squared is equal to A squared plus B squared minus 2AB times the cosine of C. Plug and chug, guys. We're solving for C. Okay, here we go. It's going to be 175, which will get squared, plus 396, which will get squared, minus 2 times 175 times 396. I apologize, multiply that by cosine of 28 degrees. Sorry about that, I had to just sort of drop it down there a little bit. Anyway, at this point, guys, you should be getting very, very comfortable with your calculator. 175 squared, 396 squared. You will add those together. We'll wind up with 156,816 plus 30625 minus 122,376.5364. Again, right, you don't want to lose any of those decimal places. So what I did, cosine of 28 times 396 times 175 times 2, that gets me this number. 175 squared, this guy. 396 squared, this guy. Scratch that. Switch those. I apologize. Sorry about that. I had the right numbers in the wrong order. 625 plus 156,816. There we go. Sorry, I apologize about that. Anyway, add these together, subtract that number, you wind up with C squared is equal to 65064.4636. Whew. Take a square root. C is equal to, round, right? It says round to the nearest mile, 255 miles. So 255 miles. Now, they asked you to figure out how much farther he flew taking the non-direct route. Okay, no problem. Let's add them up. 255 plus 175. Again, don't fat finger something on your calculator. You wind up with 430. So he flew 430 miles. The direct flight would be 396. So how many more miles did he fly? Well, subtract 396. You wind up with 34 miles. So essentially, he went 34 miles out of his way. He flew an additional 34 miles to avoid that thunderstorm. All right, guys, that's the law of cosines. Remember, the law of cosines is going to be the law you'll need to use if you're given side, 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 or if you're given side, angle, side. That information requires you to use the law of cosines. And then, I know that there's 3 formulas that you're given, but you can use the exact same cosine formula every time, as long as you just label the diagram the way you want it to be labeled, which is not a problem. You certainly can do that. Once you've got the law of cosines set up, you can really solve some awesome problems using the law of cosines, which I had a great time taking a look at with you, and I'll see you next time.